Okay, this is 6.3 notes, solving rational equations. So looking at example 1, our goal here is to get one fraction equal to the other, meaning our first step is going to have to combine these two fractions by getting common denominators. So what I'm going to do is I'm going to multiply the first fraction by the opposite denominator, so the first fraction by x, and the second fraction by its opposite denominator, which is 2. So I get x over 2x plus 18 over 2x. Now I have common denominators. If I add the numerators across, I get x plus 18 over 2x. And then I'm going to bring down this other fraction, so it is equal to 3 over 2. Now I'm going to cross multiply in order to get rid of those fractions. And I now have 2 times x plus 18 is equal to 2x times 3. Okay. So simplifying this to get x by itself, I have 2x plus 36 is equal to 6x. I'm going to subtract the 2x over, and I get 36 is equal to 4x. Divide by 4, x is equal to 9. Here on number 2, we already have a fraction equal to another fraction, so I can go straight into cross multiplying. So I have 3x plus 5 times 2x plus 7 is equal to 2x plus 7 times 5x minus 2. Well, if I have the same things on the opposite sides, I can cancel them out. So I have a 2x plus 7 and a 2x plus 7, both being multiplied, so I can cancel these out. So I have 3x plus 5 is equal to 5x minus 2. Solve for x by subtracting 3x, and I get 5 is equal to 2x minus 2. Add the 2 over, I get 7 is equal to 2x, which means that x is equal to 7 halves. Number 3, same thing, I'm going to cross multiply because I already have a fraction equal to another fraction. So I have 3 times 4x plus 5 is equal to 9 times x plus 1. I could reduce the 3 and the 9 and turn this to a 1 and this to a 3 because they're both divisible by 3. And then I can rewrite this as 4x plus 5 is equal to 3x plus 3 if I distribute 3n. So I'm going to subtract 3x, and I have x plus 5 is equal to 3. Subtract 5, I have x is equal to negative 2. Okay, same thing with number 4. Notice, however, that in this case, I would want to try to factor as much as possible before I cross multiply. So this x squared minus 25 is an example of difference of squares. So I could rewrite this as x plus 5 and x minus 5. So when I cross multiply, you'll notice that I'll have similar things on either side that I'm able to cancel out. So I have x squared times x plus 5 is equal to 2x times x plus 5 times x minus 5. I'm able to cancel out the x plus 5. I'm able to cancel out this x and one of these x's, so I'm just going to cross off the square. So then I am left with x is equal to 2 times x minus 5. So I have x is equal to 2x minus 5. Gonna subtract the 2x over, and I get negative x is equal to negative 5, which means that x is equal to 5. Make sure I did all that correct. Okay. Oh, I did make a mistake. I was like, this doesn't look right. when I distribute that 2 in, I forgot to distribute it here to the 5. So this is actually minus 10. Okay, so then I have minus 10, x is equal to 10. Okay, sorry about that. Okay, number 5. Notice I no longer have a fraction equal to a fraction. So I have to turn this 2 to be 2 over 1, and then I have to simplify this part here. So in order to get them to have the same denominator, I'm going to multiply the 2 over 1 by x minus 5. So then I have 2 times x minus 5 over x minus 5 minus 16 over x minus 5. So this gives me 2x minus 10 minus 16 over x minus 5, which gives me 2x minus 26 over x minus 5. I can set this equal to the other fraction on the other side, so 6 over x, and then I can start cross multiplying. So I get 2x minus 26 times x is equal to 6 times x minus 5. So if I simplify this, I have 2x squared minus 26x is equal to 6x minus 30. And since I have that x squared there, I need to move everything that is on that right side over to the left because I want it equal to 0. So 2x squared minus 26x minus 6x plus 30 equals 0. Gives me 2x squared minus 32x plus 30 is equal to 0. I can take out a GCF of 2 and I'm left with x squared minus 16x plus 15 equals 0. And then I can factor this using the AC method, and I get x, so two numbers that multiply to 15 but add to negative 16, so that'd be negative 15 and negative 1, so negative 15, negative 1, 2 equals 0. So I have x minus 15 equals 0, which means x is equal to 15, and x minus 1 equals 0, which means that x is equal to 1. Those are my two answers. Okay, on this next part, this is showing us that sometimes we can get a solution that seems correct, but when we substitute it back into the denominator, we get a result of 0. And remember, we cannot divide by 0, which means we get no solution if that happens. So we'll see that example in number 6. So first, I have to get like terms on this side by multiplying by the opposite denominator. So this side by x, this side by x minus 3. So I get 2x over x times x minus 3 plus x minus 3 over x times x minus 3. So this gives me 3x minus 3 over x times x minus 3. So then I have 3x minus 3 over x times x minus 3 is equal to x minus 1 over x minus 3. Then I cross multiply, and I get 3x minus 3 times x minus 3 is equal to x times x minus 3 times x minus 1. Well, I can rewrite 3x minus 3 to be 3 times x minus 1, which means I can cancel out the x minus 1s and the x minus 3s, which means I am left with 3 is equal to x. Well, notice if I was to take this x and plug it into my denominators of x minus 3 and x, I would get 3 minus 3, which equals to 0, and I would get 3. Since I get one of my answers equal to 0, this means that automatically my answer is no solution. So x equals 3 is no longer my answer because when I plugged it into the denominator, I got 0, so my answer is now no solution. Number 7. Before I start combining like terms here, I'm going to go ahead and factor this x squared plus 2x to be x times x plus 2. which means all I need to multiply this first fraction by is x. So I'm left with 3x over x times x plus 2 plus 6 over x times x plus 2 is equal to 3x plus 6 over x times x plus 2. Then I have 3x plus 6 over x times x plus 2 is equal to negative x plus 3 over x. Then I cross multiply, and I'm left with 3x plus 6 times x is equal to x times x plus 2 times negative x plus 3. Well, I can simplify this to be 3 times x plus 2, which means I can cancel the x plus 2's and the x's. So that means I am left with 3 is equal to negative x plus 3. If I subtract 3 to both sides, I get negative x is equal to 0, which implies that x equals 0. But then I have to check my denominators. So I have x plus 2. If I plug in 0, I get 0 plus 2, which equals 2, so that's good. Then I have x squared plus 2x. If I plug in 0, I get 0. That's bad, which means my answer is not x is equal to 0. It's no solution. Okay, last problem here. Before I start combining like terms, I'm going to factor this x squared minus 7x plus 10. So I need two numbers that multiply to 10 but add to negative 7, and that's going to be x minus 2, x minus 5. So notice that means this first fraction only needs x minus 5 to be multiplied. So I have x minus 5 over x minus 5 times x minus 2 plus 1 over x minus 2 times x minus 5. This is equal to x minus 4 over x minus 5 times x minus 2 is equal to the other fraction, 6 over x minus 2. Then I'm going to cross multiply. And I have x minus 2 times x minus 4 is equal to 6 times x minus 5 times x minus 2. I can cancel out the x minus 2 on both sides. And I'm left with x minus 4 is equal to 6x minus 30. I can add the 4 over, and I get x is equal to 6x minus 26. I can subtract the 6x, so x is equal to 6x minus 26. Subtract the 6x over, and I get negative 5x is equal to negative 26, which means x is equal to 26 over 5. And then I would have to check. So x minus 2, so 26 over 5 minus 2. This is approximately 5.2 minus 2, which gives me 3.2, so that one's good. And then I have to check x squared minus 7x plus 10. So I have 26 over 5 squared minus 7 times 26 over 5 plus 10. And this is going to give me, again, this is approximately 5, so it's about 25 minus, let's say if that's about 5, that's 35 plus 10. So this gives me, remember, it's going to be greater, so let's say it's like 0.25. So it's going to be like negative 10 point something plus 10, which will give me a negative number. And if you wanted the exact number, you could type that into the calculator. And let's go ahead and do that since I have some time. So my calculator, I'm going to do 26 divided by 5 squared minus 7 times 26 divided by 5 plus 10. I should get a very small negative number, or actually a positive number. So I get about 0.64, which again is not equal to 0, so that means x equals to 26 over 5 is my answer.